So with me now is the semifinalist team from Boston University to discuss their proposal and first introduce who they are and how they got involved in this work.
Thanks for having us. So our lab here at Boston University, we conduct research in autonomous technologies and assistive technologies. So I've personally been working on autonomous driving for nearly a decade since I began the PhD in 2011. And after that, I did a postdoc, and now I'm at BU. And when I did my postdoc at Carnegie Mellon, I began thinking about the broader context of autonomous driving and highly automated vehicles. What happens when the system needs to interact with different types of people, people with disabilities. And since then, we've really been working on those types of technologies, such as indoor navigational assistance technologies, that can really provide guidance to people with visual impairments.
That's fantastic. Thank you. And maybe moving on to Matt, could you tell us a little bit about yourself, who you are, how you got involved with this?
Sure. So my name is Matt Boyd. I'm a PhD student in computer engineering here at Boston University. And I had a previous career in business IT. And I decided I was kind of done with that and wanted to switch into engineering and specifically robotics and autonomous systems. And when I told my parents I was interested in that, they're both in medicine. Their first few questions were, okay, so we have patients with this problem or this mobility challenge. What can you design to help them? And so that really got me thinking, even before I started the degree program, what kind of systems can we design to help people who kind of live every day with challenges that we might be able to design systems to engineer systems to help them with. And then I met Eshed, and it seemed like kind of a perfect fit, his interests and my interests, and figuring out how we can solve these problems.
That's great. Andres, what about you?
Yeah, I'm a second year PhD student here at BU. I'm actually in systems engineering. I come from a background in aerospace engineering, and previously I was actually working on localization systems for space exploration. Then I went to work for Caterpillar and then for a startup company in California. But it was always the same approach of product-centered rather than human-centered approach. Then when I actually started my PhD, the idea was to get involved not just in the robotics aspect, but try to center it like on the human approach. And then I actually met Eshed, who was doing assistive technologies. And we started talking about localization systems for pedestrians, just for walking. Then this project came up, and I instantly became interested because it's like an approach which doesn't just combine automated vehicles, but also assistive navigation, which was something that I was very interested in.
That's great. And Minglan?
Hello, everyone. My name is Minglan. I'm an undergrad. I'm mentored by Professor Ohn-Bar in the BU Undergrad Research Opportunity Program, and we work on a simulation of pedestrians with disability and their interaction with vehicles. And I learned a lot in the process, so thank you.
Fantastic. And Zheng.
Hi, everyone. I'm Jim Young. You can call me Jimmy. I'm the first year PhD student at Boston University working with Professor Eshed Ohn-Bar. So actually several years ago, when I did my master's at Carnegie Mellon University, I met Eshed. We worked together on a low profile robot navigating the blind people in the indoor environment. So at that time, I found such research is really interesting and it can be really helpful for those disabled people. So that's why I want to continue working on this with Eshed, and I become his PhD student, and we continue this topic.
Okay, so now that we've had a chance to be introduced to all of you and hear your interest, Matt, I was hoping you could briefly describe the project overall, the accessibility challenge it's intended to address and how it works.
Sure. So our project is called OpenGuide. It came from a pretty simple idea that most of us probably take for granted. In a typical day, if I need to use Uber or Lyft to get somewhere, it's a nearly frictionless process. I use the app to request a ride. I watch the street until I see the gray Corolla or maybe white Prius that's coming to pick me up. I hop in, monitor my journey on the way, and at the end, I can jump out and arrive safely at my ultimate destination. Our goal is to create a system that provides a similarly seamless experience throughout this navigation process for a person with disabilities. Existing step-by-step assistive navigation solutions provide only minimal utility in this type of scenario. They're often carefully crafted to operate in specific and very limited parts of this overall journey, or tailored only to certain types of users. With OpenGuide, our idea is to enable a more scalable assistive system, a system that should operate for a variety of users and across differing scenarios throughout this entire navigation process, all in a safe and personalized manner. How can we meet the real-time needs of our diverse users who have a variety of navigation skills, mobility aids, and even preferences, and do it in a context-dependent way, whether indoors, outdoors, or in the vehicle? These are the questions that OpenGuide aims to address.
Fantastic. And Eshed, where did the idea for this project come from, and how has it evolved over the development?
Yeah, sure. So over the past few years, we've been working on assistive indoor navigation systems. And as an engineer, you really want everything to work perfectly. So this is kind of a low-level thing, like the localization of the system should localize the users to a high degree, to so-and-so meters. And you'll spend maybe a PhD getting a few points more accuracy for that task. And that's a very challenging engineering problem on its own. But there was something that we didn't expect when we invited people with visual impairments to test our assistive systems. What we didn't expect was that each user reacted very uniquely to the same guidance. So this was a great revelation to us. If I gave the same guidance to two different users, they may end up meters apart from each other. And this is obviously of importance to a safety critical application like navigating to an autonomous car, for instance. So we realized that we're just scratching the surface here. And there is still lots of room to analyze systems that work for different types of people in the real world. And that led to our key idea of OpenGuide, of personalizing the system. So we really want the system to be customized to different users as it's interacting with them and learning from them in real time. That's what OpenGuide aims to achieve.
That's great, thank you. And Andres, who have you partnered with on this project, and what have they brought to the table?
Yeah, so among our partners, we have Motional, one of the leading companies here in Boston, which is focused on autonomous driving. Additionally, we partnered with Chuck Gulash, the former director of the Toyota Collaborative Safety Research Center. And between both of them, they actually combine extensive amount and years of experience in automotive research and development. We are actually working to them to develop OpenGuide to incorporate an industry perspective that would range from the product feasibility to data collection. Additionally, we are partnering with them to use some invaluable resources that will eventually be used for the real world implementation of OpenGuide and the final upcoming demo.
Fantastic. And Minglan, could you talk about how you guys have engaged with the community of people with visual impairments during the development of this project? You know, how has their input shaped the process?
Sure. We have engaged with the Carroll Center for the Blind, which is based out of Boston, and we have been collaborating on use case design, recruiting users for formative studies and data collection, as well as prototype testing. We have collaborated both remotely and in person, which is planned for later as the project progresses. We will also be working with orientation and mobility experts as a part of the design process.
And Jimmy, how has this project challenged you all the most? Or, what's the most important lesson coming out of it for your team?
Sure. So there are several fundamental challenges to inclusive navigation systems. How to operate and collaborate with diverse users is one we've been working on. Another critical one is safety, as these prototypical assistive devices are moving from the controlled environments and development labs into the real world. How do we ensure our system is safe? It is a very challenging task. The system is not and will not be perfect. In some sense, we're trying to leverage input from the user to improve the system. But here, we're talking about an application where the needs of users are still not fully understood. If there is a new user, how to ensure safety and how to avoid colliding into the obstacles and stairs. Safety is always our top concern.
Yeah. And Matt, what is your ultimate aspiration or goal for this project? What sort of impact do you think is possible with the work you're doing?
Yeah, absolutely. We want OpenGuide to operate like an expert aide or best friend who knows you really well. We want the system to guide different people in and out of a vehicle while providing them with awareness of their surroundings, including the obstacles and other landmarks critical for safe and effective navigation, allowing blind or visually impaired people to travel completely independently. One specific aspiration in our design is to enable the interaction with users to go both ways. The system should be able to get feedback from the user in order to learn and customize automatically to their individual needs. We want our visually impaired users to take an active role as an engineer and designer of this system, make them an active participant and teacher to personalize and customize the interaction. Teaching us autonomous systems can be incredibly empowering and ensure people with disabilities are not left behind in the development process. This invaluable real-time feedback from the user can also be used to increase the scope, adaptability, and effectiveness of our system over time.
Thank you, Matt. And while we're thinking about that broader vision of AVs and social impact, Minglan, I was curious, how does your work on this project fit into that bigger vision?
So the Inclusive Design Challenge brings important focus on accessibility in automated transportation and mobilities. We realize that any research they do will have a limited impact unless the technology is accessible to all kinds of people. People with various disabilities may each react fairly different when interacting with an autonomous platform. For instance, pedestrians with disabilities are at an increased risk of daily traffic injuries among pedestrians, especially during critical navigation junctions, such as intersections. Autonomous vehicles and their decision have an opportunity to transform our lives for the better. We want our learning data set and tools to reduce the barriers of design and development of accessibility-centered systems. Unless we solve these barriers, the capacity and impact of systems will continue to be narrowed and limited. OpenGuide provides a first step in the long journey of realizing inclusive mobility systems.
Well, thank you all for joining us today here at PAVE, and congratulations again to you and your entire team at Boston University on being selected as semifinalists for the Inclusive Design Challenge. Thank you all so much, and congrats.
Thank you.
Thank you.
Thank you.
Bye.